Yeah. Okay, I am Roman Vinicio, and I'm going to show how to solve the fifth problem of the exam, that is about astronomy, how to calculate the density of a star, and knowing the radius that we can watch. And here we have the given integral, and they tell us this value just to be able to work with. Now we're gonna substitute this value, so we complete our integral. And it's just substituting in algebra. We're gonna get here. Then we're gonna use this root we have here to create a triangle. After that, we will determine by trigonometry the secant angle will be r, that is our hypotenuse, over the s, that will be the adjacent catetus. Then we're gonna work the tangent for later be able to integrate with it, and we are gonna integrate our r to dr to get our the angle that will be the derivative of secant, that is secant tangent, multiplying the s as a constant. Now these values we have here, we're gonna substitute it in the original integral. So where we had an r, we're gonna have now a s secant, and where we had an r minus r, we're gonna have now another secant, and where we had the dr, we are going to have our secant tangent, the angle, also where we had the root, will turn into s tangent. Now we killed what we can kill, this s with this s, the tangent with the tangent, and we get to this integral. Okay, now we're gonna work with these binomials that don't let us integrate easily, so we split it and we get our three first integrals. That will be this one, that is a direct integral. This one that we are gonna work with property we have, and this another one that we will have to split again. So this we turn it because it's secant square. There's the derivative of tangent, so it will be the integral. Then we got the property that will be our power 1 minus or power minus 1 secant angle tangent angle plus 1/2. Well, no, this will be our power minus 2 over our power minus 1. So this time will be 1/2, and the secant will be the power minus 2. So it was a 3, now will be a 1. And finally we split this one with the property of secant square. We turn it into 1 plus tangent square. Okay. We follow next step. We already have this part. Now we multiply the constant for this another part. We are going to eliminate later the 2's, and then we integrate this one, that is also a direct integral, that will give us a natural logarithm, and also eliminate after the 2's, secant angle plus tangent angle. Now we work with the first part of the splitted integral. We just prepare it, and we have secant square that is multiplying the 1, and secant square multiplying tangent square. Their tangent will be the u, and secant will be the du. So finally we got this integral that, as we had all this before, now we are just changing this part, that will be tangent, and this will be the u to the n. Okay, so now it's where it turns interesting again. We're gonna take back the properties we already used and turn it again into our functions. So we have to use all the s we can, so we eliminate something before. Now the r squared is multiplying the tangent and the s, so we have tangent s, we turn it into a root. Same thing here, we have a s squared, so we are gonna take one s for the second angle and the tangent angle. So we will have one of these ones and one of these ones multiplying r and root. Next, where we have this, we cannot use this one because of the logarithm, so we're gonna work with this part we had here, and we get the s down below. Now we had this tangent, and we will take one of the s and take the root back, and here we have an s cube, but we have also a tangent cube, so we turn this into a cube, we also turn this one into a cube. They are equal, so we got this. Now we are gonna split the integral and change the values. So then we had an r squared here, and this r will turn into another r squared, and we had before taken out the roots, so we can't like work as a sums with the r's, and now we eliminate them. And then we had the sum of 1/3 that is here, we had the 1/3 and the root. Okay, the only thing we're doing is changing the r's we have here for an eigen r. Then we go to the next step, that will be the logarithm, that will just give us this equation, changing the r's. And now we get to cut some things, because we're going to go here where we had the sum before, the same than before, but now the root that is multiplying everything will be 0. Then the 1/3 will also have a 0 inside, and the logarithm will turn into a logarithm of 1, that is 0, and we get to shorten our equation. Now we continue with the function, and it will be the s squared times root of r. Okay, we can read it. And now this part, we are going to take these values out, so we can separate or like associate the roots, and this is the shorter part, the shorter way we can have this, so we are not going to move it. Then we go here, we have the root outside, and now we're gonna multiply this for everything here and take the s against the s, so we get 2s squared plus the r that is multiplying the 1/3, but we're gonna take out the 1/3 because we already used it here and it's just multiplying here. It is dividing here, but we take it out too, so it's correct to do it. And here is our shortened part. That's it. We complete our integral, and now we can just change the values we have and know the density of our star.